Okay, today what we're going to be looking at is, or we're going to be starting a unit on what we call curve sketching. This is basically where we find characteristics of functions like increasing, decreasing. I think you've talked about concave up, concave down. If not, we'll review that. But we're going to talk about all the characteristics of a function. But before we begin, we have two theorems that we need to go over. And the first one is the intermediate value theorem, and the second one is the mean value theorem. And you're going to have these theorems memorized as well as their name. Okay, so you need to know intermediate value theorem. Okay, intermediate value theorem says is if f is continuous on the closed interval AB and k is any number between f of a and f of b, then there is at least one c in AB such that f of c equals k. So what this is basically saying is that k is a y value. Let me get a pen that works. So k is a y value. And we're saying if that y value is in between the y value at A and here the y value at B, then we have some x value c in our interval between A and B such that f of c equals k. So basically what it's saying is that we can guarantee that there is a y value, every y value between f of a and f of b or vice versa, okay? Now the conditions that you have to state when answering these, and these are kind of wordy problems, you need to state that the function is continuous and you need to show that k is between f of a and f of b. The y value we're interested in is between the two y values of the endpoints. And then your conclusion is there must be at least one c in a to b such that f of c equals k. So let me show you how this works. It says apply the IVT, if possible, on 0 to 5 so that f of 1 for the function f of c equals 1 for the function f of x equals x squared plus x minus 1. Okay, so the first thing we have to do is decide if f of x is continuous. So yes, f of x is continuous, so IVT applies. This is just a regular quadratic. Okay, then we need to figure out what the y values of our endpoints are. So we're going to do f of 0. So when I plug in 0, I get 0 plus 0 minus 1. And then we're going to do f of 5. So when I plug in 5, I get 25 plus 5 is 30, minus 1 is 29. So now what I need to show is that 1 is in between those two values, which it is. So what we're going to do when we write our answer is we need to write our statement. So we're going to say, since f of x is continuous, and, okay, now we're going to put our 1 in there, f of, let me put it down here, f of 0 less than 1 less than f of 5. So that's telling me that my y value I'm interested in, this guy right here, is between the y values of the endpoints. And now we say then by IVT, and then we start rewriting our statement, there must be a c in our interval 0 to 5 such that f of c equals 1. Okay, so that's what we're going to be looking at. That seems really dark for you guys, doesn't it? Anyway, let me try zooming in a little bit. Okay, that seems better. All right, so let's try it again. Use the intermediate value theorem to show that f of x equals x cubed plus 2x minus 5 has a 0 in the interval. Okay, so remember, if it has a 0 in the interval, that means that we want f of x to be equal to 0. So we're going to do the exact same thing. This is continuous because cubic is continuous. So we are going to find the y values at our endpoints. So if I plug in -1, that would be -1 minus 2 would be -3, minus 5 would be -8, And then if I plug in 3, I would get 27 plus 6 is 33, minus 5 is 28. So again, 0 fits in between the two y values, so we can write our statement. Since f of x is continuous and f of -1 is less than 0 is less than f of 3, then by IVT, there must be a C in our interval -1 to 3 such that f of c is equal to 0. So the answer is long, and I promise, you guys try and come up with your own sentence and you leave things out. If you will just follow this pattern, then it was so much easier to write your answer. Just memorize the way it needs to be written. All right, number 3, it says let g be a continuous function. Selected values of y equals g of x are given in the table to the right. For which value of k will the equation f of x equals 3/4 have at least 2 solutions on the interval from 2 to 8? So this is my y value. So I need to have a y value above 3/4 and a y value below 3/4. So I'm not going to get a y value in here that's going to be 3/4, and I'm not going to get a y value in here that's going to be 3/4. So my only hope is to get a y value between those two intervals. Well, what that means is that k has to be less than 3/4. It has to be below the y value that we're interested in. So if I look at these, that one, that one, that one, so this one is the one that is below 3/4, okay? So that's what we're looking, this is like a typical multiple choice style problem on the AP exam, okay? So you just gotta know that this guy has to be below the y value that you're looking for. All right, let's see what's next. It says the function f and g are continuous for all real numbers. The table to the right gives values of the function at selected values of x. The function h is given by h of x equals g of f of x plus 2. Explain why there must be a w for 1 to 6 such that h of w equals 0. Okay, so again, this is a y value that we're talking about. So anytime we're talking about a y value, we're using intermediate value theorem. So if we want to know if h of w is equal to 0, then we've got to know what h of x is at the two endpoints, 1 and 6. So I'm going to do h of 1 first, which would be g of f of 1 plus 2. So f of 1 is 2, so it would be g of 2 plus 2. So g of 2 is -12 plus 2 is -10. Then I'm going to do h of 6, which would be g of f of 6 plus 2, which would be equal to, let's see, f of 6 is 8. So g of 8 is 28 plus 2 makes 30. So again, notice that I've got one y value that's below 0 and one y value that's above. So it says explain why there must be a value. So we start our sentence. Since, this time our function name is h of x, so since h of x is continuous and, okay, so now we're going to do our h of 1 is less than 0 is less than h of 6, then state your theorem by IVT, there must be a C in 1 to 6 such that, h of c is equal to 0. Okay, so again, same sentence over and over and over again. All right, so hopefully that makes sense because now we're going to move on to our next theorem, which is the mean value theorem. The mean value theorem says if f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there is at least one number in C, one number C in AB such that f prime of C equals f of b minus f of a over b minus a. Now, the way we normally say this is I rock equals a rock. The instantaneous rate of change equals the average rate of change. Okay, so what are your conditions? What do you have to state in the since part of the sentence? You have to state that the function is continuous and differentiable, and you have to state what the average value is, the average rate of change is. And then your conclusion is there is at least one C in AB such that f prime of C equals K. So if you notice, when we were doing intermediate value theorem, we were talking about the y value on the function h of something. On mean value theorem, we're talking about the derivative of the function f prime of something. Okay, so don't get those confused. That's how you know which one to use. If you're talking about f prime, then you need mean value theorem. If you're talking about f, then you need intermediate value theorem. Okay, so let's try one. It says find the values of c in the interval 1 to 5 that satisfy the mean value theorem for the function f of x equals 3 minus 5 over x. So the first thing that we need to do is we need to find our average rate of change. So we need to do f of 5 minus f of 1 over 5 minus 1. So that would be, let's see, f of 5 would be 3 minus 1, so that'd be 2. F of 1 would be 3 minus 5, so that'd be negative 2 over 4. So my average rate of change is 1. So what I'm saying is that somewhere in the interval 1 to 5, f prime of c is equal to 1. Now, on this one, it says find the value of c. So what we need to do is we need to find f prime of x using our derivative rules. So the derivative of 3 goes away. The derivative of negative 5 over x is a positive 5 over x squared. Remember that is a minus 5x to the negative 1. We bring our negative 1 in front, which turns it positive, and then we subtract 1 off of our exponent. Okay, so we want that average rate of change to be equal to 1. Well, I'm going to make it fraction over fraction and cross multiply. So that gives me x squared is equal to 5. So x is equal to positive negative square root of 5. Now, both of those are not our answer because we have to be in the interval 1 to 5. So the negative goes away, and so our answer is that the c value is equal to square root of 5. Okay, so it's just average rate of change equals derivative, instantaneous rate of change. All right, find the equation of the tangent line to the graph of f of x equals 2x plus sine x plus 1 on 0 to pi at the point which is the solution to the mean value theorem. So remember, the solution to the mean value theorem is finding the point C when the average rate of change is equal to the derivative. So let's find average rate of change first. So we're going to do f of pi minus f of 0 over pi minus 0. Now we're going to plug in. So f of pi would be 2 pi plus sine of pi, which is 0 plus 1. So it would be 2 pi plus 1 minus, let's see, f of 0 would be 0 plus 0 plus 1. So that'd be 1 all over pi, which would be 2 pi over pi, which is equal to 2. All right, so average rate of change is 2. So now I want to take my derivative, f prime of x, and I want to find the x value where my derivative is 2. So the derivative is going to be 2 plus cosine of x, and we want to know where that's equal to 2. So that would be cosine of x is equal to 0, so x is equal to 0, and pi, no, that's not right. That's where its cosine is 1. So x would be equal to pi over 2 and 3 pi over 2. That's where cosine 0. Okay, now in our interval, though, the value that's between 0 and pi is going to be pi over 2. So that's our C value. That's our solution to the mean value theorem. Now we've got to write the equation of the tangent line. So remember, there's two things that you need for a tangent line. You need a point and you need a slope. So we need f of pi for our point, which would be 2 pi, what did we say, plus 1. And then we need our slope, which would be f prime of pi. Well, we've already decided that it's 2. Sorry, we're not doing f prime of pi. We need to do f prime of pi over 2 because that's our C value. So let's do that again. F of pi over 2 would be pi plus sine of pi over 2 would be 1 plus 1, so it would be pi plus 2. Let's do this right. Okay, so now we want f prime of pi over 2. Well, here's f prime, so cosine of pi over 2 is 0 plus 2 makes 2. So now I can write my tangent line. Y minus 2 is y minus, I'm screwing this up. Okay, right, let's go to the point. Y minus pi plus 2, there's the y value, equals the slope 2 times x minus pi over 2. Okay, that was pretty bad. But hopefully you get it. Our C value is pi over 2. So we're going to take pi over 2 and plug it into our function and our derivative. So when we plug it into our function, 2 times pi over 2 is pi. Sine of pi over 2 is 1 plus 1. So we have pi plus 2. And then when we take our pi over 2 and plug it into our derivative, cosine of pi over 2 is 0. 0 plus 2 makes 2. Which is, we really didn't have to plug it in there because we knew our slope was 2 from the average rate of change. Anyway, there's our equation. All right, let's see what else we've got. All right, so these are some AP style problems. So it says, given a function h of x that is continuous and differentiable on 3 to 7, with h of 3 equals 4 and h of 7 equaling 9, which of the following must be true? Circle all that apply. Okay, so what I like to do with these is I don't know why that pen's not working. How about if we try another one? Okay, so I like to draw myself a grid and plot my points. So I know if h of 3 is equal to 4, I've got that point right there, and then h of 7 is equal to 9, I have that point up there. So my y values need to be between 4 and 9, okay? So there exists a real number p such that h of p equals 5 for p between 3 and 7. So this is intermediate value theorem. Do we, or can we, I guess, guarantee a y value of 5? Well, since 5 is between 4 and 9, then the answer is yes, as long as the x values stay between 3 and 7, which is correct. So this one is a true statement by IVT. Next one says h of 5 is 5. Well, h of 5 could be 5, but it doesn't necessarily have to be 5, so this guy is false, okay? Well, it's not really false, it just means it doesn't have to happen. And then the last one, there exists a number p such that 8 prime of p is equal to 5/4 for 3 less than p less than 7. So this one is getting at our mean value theorem because we're talking about h prime. So the only slope I can guarantee is the slope between these 2 points. So if I find the slope between those 2 points, I've got 9 minus 4 over 7 minus 3, which would be 5 over 4, which is true, so this guy is true as well. So my answer are 1 and 3, okay? Remember, this one came from the IVT, and this one was from MVT. All right, one more. It says a car travels on a straight track. During the time interval from 0 to 60, the car's velocity, measured in feet per second, is continuous and differentiable function. The table below shows selected values of a function. For 0 less than t less than 60, must there be a time t when v of t equals -5? Okay, so we have our function v of t, and we're trying to come up with information about v of t. So this means we're using IVT. This is a y value. So does there have to be a y value of -5? Well, that means we've got to have one y value that is smaller than -5 and one y value that is bigger than -5, which happens between 35 and 50. So we say yes, since v of t is continuous, and we say v of 35 less than -5 less than v of 50. Now we write our conclusion. Then by IVT, there must be a t, that's the variable that it called it, in, and then we use our interval, 35 to 50, such that v of t equals -5. Okay. All right, next one. For 0 less than t less than 60, must there be a time t when a of t equals 1/2? Okay, so on this one, we're talking about a of t, which is the derivative. Remember, a of t is the derivative of velocity. So if we're talking about a derivative, then that means we have mean value theorem. Now we're going to start using the endpoints that they gave us and see if that works. If not, then we'll have to come inside the interval and see if we can find something that works. So let's just try the endpoints. So we're going to do v of 60 minus v of 0 over 60 minus 0. Remember, we're doing average rate of change. And so this is the derivative function. This is v prime, so we want to use v here. So v of 60 is 10 minus -20 all over 60. So that would be 10 plus 20 is 30, so that would be 1/2. So we hit our derivative value that we were looking for. So now we're ready to write our sentence, our justification. So we say, answer the question, must there be a time t? So we say yes, since, okay, so now conditions for this one. We need v of t is continuous and differentiable. Okay, so you've got to get both of those in there. And v of 60 minus v of 0 over 60 minus 0 equals 1/2. Okay, so that's the conditions. We've got continuous, differentiable, and the average rate of change. Now we can write our conclusion. So then, by this time it's MVT, there must be a t in 0 to 60 such that, now we state our v prime of t, which is equal to a of t, equals 1/2. Okay? All right, so I think that's all of our, oh, one more. Okay, so contaminated water is being pumped from a retention pond. R of t is both continuous and differentiable. and represents the amount of water that is left in the pond at time t minutes in hours, at time t measured in hours. So we've got gallons and we've got hours and we've got gallons. All right, so using correct units of measure, find the average rate of change of R of t from t equals 3 to t equals 21 hours. So remember, average rate of change would be R of 21 minus R of 3 over 21 minus 3. So R of 21 is 7,000 minus R of 3 is 17,000 over 21 minus 3 is 18. So 7,000 minus, that would be a negative 10,000 over 18. I'm just going to leave it like that. So my units would be my R units divided by my T units. So that would be gallons per hour. Okay, estimate the rate that the water is being pumped at time t equals 4. Use correct units. Explain what this value means in the context of the problem. Okay, so now we're going to do the exact same thing because it says estimate the rate, that's supposed to be a capital E, at t equals 4 hours. Well, when we have a table, the only way we can estimate a rate is by doing average rate of change. So we're going to find the two closest points to 4, which are right here, 3 and 6. So I'm going to do the average rate of change of that. So I'm going to do R of 6 minus R of 3 over 6 minus 3, which is going to be 16,000 minus 17,000 all over 3, which is going to be 1,000 over 3. Units for that are still gallons per hour. Now, what does that mean? Actually, that should be a negative 1,000, shouldn't it? 16,000 minus 17,000. Okay, so what does that mean in the context of the problem? So that means water is, what are we in a pond? Leaving the pond at approximately 1,000 over 3 gallons per hour at t equals 4 hours. Okay, so we don't put it negative because we've written the word leaving. Okay, so leaving indicates that it's a negative rate. Okay, is there a time on the interval from 9 to 12 at which R prime of t is equal to negative 500? Justify your answers. So again, this is R prime of t, so that's going to be MVT. So my interval is from 9 to 12, so I'm going to do R of 12 minus R of 9 over 12 minus 9, which is going to equal, let's see, R of 12 is 13,000 minus R of 9 is 14,500 all over 12 minus 9 is 3. So that would leave us with negative 1,500 over 3, which is a negative 500. All right, so we've got to write our sentence, our statement. So we say, is there a time t? So we say yes, so we can answer the question. Since R of t is, remember we're doing MVT, so we need both continuous and differentiable, and R of 12 minus R of 9 over 12 minus 9 is equal to negative 500 gallons per hour, then by IVT, now I just start writing the sentence again, or the prompt again. There must be a t in 9 to 12 such that R prime of t is equal to negative 500 gallons per hour. Okay, I hope you're getting familiar with that sentence. It's the same sentence over and over and over again. All right, last one. Is there a time, I did not do well with punctuation on this. Is there a time on the interval 3 to 15 at which R of t equals 15,000? Okay, so 3, we're at 17,000, and at 15, we're at 10,000. So yes, 15,000 is in between that. So what we need to say is R of 3 is equal to 17,000, and R of 15 is equal to 10,000. All right, so 15,000 fits in between, so we're ready for our statement. So we say yes. This time we're using IVT, so we only need continuous. So since R of t is continuous, and now we need to bracket our given y value. So it would be R of 15 less than 15,000 less than R of 3. Then, this time it's by IVT, and we write our conclusion. There must be a t in 3 to 15 such that R of t equals 15,000. Okay, I think that's it. Yep, that's it. So if you have any questions, then let us know, but you really have to kind of commit to memory the statements for both the MVT and IVT. And you've got to remember, when they're asking you about a derivative of the original function or of the given function, then you use MVT. If they're asking about a y value of the given function, then you're using IVT. All right, if you have any questions, come see us, guys. Bye-bye.